Okay, so in assignment 59, I want to focus on setups for partial fraction decomposition situations. I'm not going to tell you which case we are. I just want you to set them up. I think you're more than welcome to try solving for the constants if you want. Go back and watch the first video for assignment 58. You'll see lots of practice multiplying by the least common denominator and solving for A, B, and C, etc. But here, I kind of really just want to focus on setting up each case. Okay? I'll do the first 3 or 4, and then you should definitely, we should go through the next, I don't know, 10 cases and see what happens. Okay? All right, so first one, 3x plus 1 over x squared minus 5x plus 6. Well, when I factor that denominator, x minus 2, x minus 3, I see these aren't the same, and so I know I'm talking about case 1. And I put an a over one of them and a b over the other. Okay? Case 1, non-repeated linear factors. What about this one? 3x plus 1 over x minus 1 squared. Well, here, this is repeated linear factors. These things are linear, and I have more than one of them. So this is case 2. And so I'm going to have a over x minus 1 to the first and b over x minus 1 to the second. And again, if this was a 3, I'd also have a plus c over x minus 1 to the third. In fact, I'm going to write that down. Okay? So whatever this power is, I have to represent all the possible power combinations. Our original problem, though, was this one. Okay. That, by the way, is case 2, where we have repeated linear factors. Next, what about this one? 3x plus 1 over x times x plus 2 squared. What do we do here? What's the setup here? Well, that's not repeated, so I can just do a over x. But here, I have an x plus 2 times an x plus 2, so I'm going to need b over x plus 2 and c over x plus 2 squared. Now, some people are saying, Mr. Kukla, this is going to be x squared plus 4x plus 4 on the bottom. Shouldn't this be, since this is x squared on the bottom, shouldn't this be cx plus d? And the answer is no, because this is repeated linear factors. And what I'm looking at is this thing. Not how often I have them, just this thing. I need 1 degree less than this. This degree is first degree. 1 degree less would be 0 degree. And so I've got x to the 0 up there. Okay? So there's my setup. And then this last one, what could I do in this situation where I have 3x plus 1 over x squared plus 1, x minus 1? Well, they're not the same. So there's a non-repeated linear, and that's a non-repeated irreducible quadratic. My impulse is to put a over this and then move on to that. But I think I'm going to start here. Okay, so we've got x squared plus 1 plus and x minus 1. Remember, this needs to be 1 degree less than that. So ax, and not all lines pass through the origin. So I need that b value. And then over here, because I have something linear, I'm just going to have a c. This is case 3. This is case 1. Non-repeated, irreducible quadratic. Can't factor that unless I bring in imaginary numbers, and no imaginary numbers for us. Okay, so here are the setups, or here's the first one that I would like you to set up, please. Okay, pause the video, write the setup for that, come back when you're done. Wow, that was fast. Did it go well? Are you comfortable with this? Did you say that this would be a over x plus 2 plus b over x minus 1? That's great. And if you had written a over x minus 1 plus b over x plus 2, that would also be great. Good job in either case. Okay. What about this one? 4 over x squared minus x. Please write the setup for that. Okay, so factoring tells me that this is a over x and b over x minus 1. This is not an irreducible quadratic. I can factor this, so I must. How about this one? X over x squared plus 2x minus 3. What's the setup going to be there? Welcome back. Did you factor this? X plus 3, x minus 1. And so we've got a over x plus 3 and b over x minus 1. Be careful with factoring. If you factor this wrong, setup's wrong, the whole rest of the problem is wrong. You can never have that time back in your life again, ever. So you might as well pay attention to your factoring. It may well be worth, when you're at this point here, that you, in your head, FOIL it out and make sure you get back here, all right? Okay, how about this one? 3x plus 7 over x plus 2 squared. Will you write the setup for this one? Nice, good, let's go. A over x plus 2 plus b over x plus 2 squared. This is case 2. It's repeated linear factors. Whatever that power is, I've got to have that many partial fractions here. How about this one? X squared over x minus 1 squared and x plus 1. You do the setup for this one. Hey, welcome back. So I see the repeated, and I only have one of those. So a over x plus 1, b over x minus 1, and c over x minus 1 squared. You could, of course, write this as a over x minus 1 plus b over x minus 1 squared plus c over x plus 1. This person's a and this person's a will be different, but when we're all done finding a and b, c, we'll see that everything is the same. These will be the same, these will be the same, and these will be the same. And we'll be looking at the same. So either one of those is a fine setup. What if I have this? X plus 1 over x squared x minus 2. Can you set that one up? Did you have a over x, b over x squared, and c over x minus 2? Remember, that x squared is a repeated linear factor. It's really x minus 0 squared. I've got to represent both possibilities, x minus 0 to the first, as well as x minus 0 to the second. Okay? And this one, what would you do here? 2x plus 4 over x to the third minus 1. Pause the video and think about that for a minute. Hey, welcome back. Did you factor the denominator? I don't need to worry about factoring the numerator, but I definitely have to factor the denominator to get to something that looks like this so I can do my setup. How is it that I factor a difference of cubes again? Yes, we did do that in the Algebra Basics unit. You might want to watch that first video on factoring again. No, really. You need to get comfortable with this. You need to be able to see it, or you're never going to see it. So, how does that factor? Well, I remember that factors as x minus 1, x squared plus x plus 1. On top, we've got our 2x plus 4. Well, here's a non-repeated linear. And this is an irreducible quadratic. I can't factor this unless I use imaginary numbers. So my setup is going to be a over x minus 1, and then bx plus c over x squared plus x plus 1. This is 1 degree less than this, and I need that plus c because not all linear equations go through the origin. Some are shifted up, some are shifted down, and so I have to respect all those possibilities by setting up that bx with a plus c. Okay, so what can you do with this one? We've got x plus 4 over x squared plus 4. What's that setup going to look like? Yeah, we've got a non-repeated linear, and we've got an irreducible quadratic. Oh, why don't we just go through and find A, B, and C? I mean, we've just done the setups and all the others. Will you please finish this problem? Come back when you're done. Hey, did you remember to multiply everywhere by the least common denominator? Do you know why I write this out like this? It's not because I enjoy it. It's not even because I think you need to see it. It's because I got so tired of getting these problems wrong because I tried to do this in my head, as many of you like to do. Don't worry, I know your secret. Yeah, and so, no, don't. I just, yeah, these things take too long. Just, why would you want to screw it up right at the beginning? Because you thought, well, I got it all taken care of. I don't need to write it out. Okay, this cancels that. We have an a and an x squared plus 4. And then we have our bx plus c. This cancels that. All we're left with is this x. So there's my setup. Now, do I want to use magic numbers? Well, look, I've only got one magic number, 0, and I've got 3 letters to find. 3 of these constants to find. I'm never going to be able to do this without using systems. I may start with magic numbers, but that's just going to force me into a systems position, and I'm going to have to do systems anyway. So I'm just going to start by doing systems here. Okay, so I have x plus 4 equals ax squared plus 4a. Don't forget to distribute this, bx squared plus cx. So let's make some stuff together. No x, 4 equals 4a, a equals 1. X to the first, fabulous, x equals cx. I divide by x, I get c equals 1. And now what about this x to the second stuff? There is none over here. So 0 of those, ax squared plus bx squared. And if I divide everywhere by x squared, I get 0 equals a plus b, which would be a little frustrating if I didn't already know what a was equal to. And so I know that b equals negative 1. So I'm going to take these values and plug them back in here. My a value is 1, my b value is negative 1. Some people write it like this, other people write it like this. Careful, this has to go to that. Yeah, I don't like that either, so I'm going to write it like this. And then my c value was 1. There we go. All right. That was this one. How about this one? Then you go back to doing just the setup on this. X squared plus 9 over x to the 4th minus 2x squared minus 8. I'm sure glad we did that factoring before. You'll need some factoring practice for this. Or at least some factoring confidence for this. Were you able to factor that? It's supposed to factor the same way x squared minus 2x minus 8 factors, which is x minus 4, x plus 2. But instead of this becoming x and x, ours need to be x squared minus 4, x squared plus 2. Now, that we can take further. That can be x plus 2, x minus 2. But this only factors with imaginaries, so I'm not going to take that any further. So my setup, a over x plus 2, b over x minus 2, and irreducible quadratic x squared plus 2, I need a cx plus d here. Okay? All right. Can you do this setup? We've got 10x squared plus 2x over x minus 1 squared and x squared plus d. Please do the setup for that. Okay, so here's a repeated linear factor, a over x minus 1, b over x minus 1 squared. And here's an irreducible quadratic. The only way to factor that is with imaginary numbers. I'm not going to use imaginary numbers, so I need a cx plus d on top of this x squared plus 2. Okie doke. My least common denominator is this, and I would multiply all these things by it. Okay? Nice. We're not going to do that. So what I will say is setup, once we get to the setups, people seem pretty confident in using either magic numbers or systems to get where they want to go in finding those constants. We've only been 17 minutes, so maybe we'll do one or two more of those solving ones. But first, I actually want to run through something called improper rationals. Improper rationals is where the degree of the top is either greater than or equal to the degree of the bottom, degree of the denominator. And instead of top, let's say numerator. Okay? And so what I mean by here is, like if I have x squared minus x and x squared plus x plus 1. How do I deal with situations like this? You know, these degrees are the same. Or how do I deal with this situation where I have, for example, x to the third over x squared minus 1. Minus 1? Plus 1. I want plus 1. No, I want minus 1. Yeah, that was right the first time. So, what do I do in situations where the degrees are the same or the degree on top is bigger than the degree on the bottom? We haven't actually seen that either in this video or the last video where we have one of these situations. And these come up, and actually there is that thing that we do in calculus a whole lot. Well, sometimes it has to be done with these improper expressions, and always what I'm about to show you is really helpful for those people. So what we're going to do is long division. No, really, we're going to use long division. So here's how long division works in this situation. I'm going to take that x squared plus x plus 1, and I'm going to divide it into x squared minus x. What do I multiply this by to turn it into that? No worries, that's just a 1. So I'm going to have x squared plus x plus 1, and I'm going to subtract. This minus this, they cancel. Negative x minus x is minus 2x. And then 0 minus 1 is negative 1. And so this is my remainder, because I'm not multiplying this by anything to turn it into x. No. So this is done. And so I would have 1 plus the remainder over the divisor. 1 plus that negative 2x minus 1 over x squared plus x plus 1. Now here's the sort of nifty thing about what's just happened here. Remember, we started off with x squared minus x over x squared plus x plus 1. This is an irreducible quadratic. I need an ax plus b on top of this. ax plus b. Look at that. It's done for me. That wasn't so bad. And look, there's this little extra bit out here. So, yeah, long division. Pretty cool. Took care of all of it. No, it doesn't always work that way. And no, I can't do it on the other cases that we saw in all the other videos. And yeah, so let's look at this one. This was the other case of x squared minus 1. Now, I'm tempted to say a over x minus 1 plus b over x plus 1. However, yeah, I'm not going to do that. Instead, because this degree is greater than or equal to this degree, I'm going to do long division. And I'm certainly not going to forget the 0 placeholders. 0 placeholders. What do I multiply this by to turn into this? And then I distribute, I get x to the third minus x. And I subtract. These cancel. There's no x squareds to bring down. 0x minus a minus x is x. I guess I could bring down the plus 0. But remember, I'm now going to take that remainder and put it over the divisor. Now look, see, this degree is bigger than that. I'm going to do partial fraction decomposition just on this. And when I'm all done, I'm going to make sure there's an x in front of it. So, partial fraction decomposition, x minus 1, x plus 1. So, yeah, I'm holding this off to the side. Just this part. A over x minus 1, b over x plus 1. And I multiply everywhere by x minus 1, x plus 1, x minus 1, x plus 1, x minus 1, x plus 1. And no, really, I got you. It's not for you, it's for me. But really, if I was making those mistakes, you will probably make them too. So you might want to do this and cancel out those, and cancel out that, and cancel out that, and get x equals a, x plus 1, plus b, x minus 1. Okay, I see 2 constants and 2 magic numbers. Let's go. X equals 1 makes this go away. 1 plus 1 is 2a. And so a equals 1 half. And now if I use x equals negative 1, this one goes away. Minus 1 is minus 2b equals minus 1. And so b equals 1 half again. That's interesting. So what's this look like? Well, remember we had a over x minus 1, and we had b over x plus 1. So we're going to take this a and this b and plug them in here. And so I'm going to end up with 1 half over 1 half over x minus 1 plus 1 half over x plus 1. Careful. Remember the long division? Don't lose that x. And, you know, I kind of agree with the book about not wanting to have fraction-y fractions. So my answer would probably look like this. Okay? And yeah, we will need this in calculus, which is why we're taking a look at it now. You won't have any improper on your assessment. Really, don't stress about it. I just wanted to show you. Will you do me a favor and solve this one, please? 3x plus 7, x plus 2 squared. Will you do the full partial fraction decomposition on that? Pause the video. Come back when you're done. Hey, welcome back. Did you have the right setup? X plus 2, b, x plus 2 squared. And remember, this times this is not the least common denominator. This times this, you're going to end up getting stuck and very sad. So don't do that. This is the least common denominator. X plus 2 squared. So cancel, cancel. 3x plus 7. Cancel, cancel. 4a. Oh, it was squared, sorry. So I have one of these left over. I took one of them away. I still have one. And here, both of them go. And I just have that b value. Okay, I'm going to do systems. 3x plus 7 equals ax plus 2a plus b. I take my x to the first stuff and I put it together. 3x equals ax, divided by x, I get a equals 3. I'll take my stuff that doesn't have any x's and write an equation with those things and plug my a value in there. 2 times 3 is 6, and so I'm going to get b equals 1. So my partial fraction decomposition should be 3 over x plus 2 plus 1 over x plus 2 squared. Good, good? Okay. This is the level of difficulty I think you should be prepared for. All right? Some of the things we've looked at, really scary looking. Just as an introduction, don't stress about those right now. Just make sure you can do something like that problem. Okay? Did you want another one? All right, well, I mean, just in case. X plus 4 over x squared plus 4. Because some people want to practice with that irreducible quadratic. So try this one, set it up, find your constants, and come back when you're done. Hey, welcome back. I've got an a over x plus a bx plus c over x squared plus 4. My least common denominator, it's right there. In this case, it is this times this. But it isn't in case 2, so always use this. All right? So we're going to have x squared plus 4, x squared plus 4, all of this stuff times x squared plus 4. These cancel these. This cancels that. This cancels those, but I do have to distribute the x to each of these. Actually, I could just leave it as bx plus c times x. All right, so magic numbers, systems, what do you say? Well, I only see one magic number, x equals 0. And when I only see one magic number but 3 constants to find, yeah, I don't use magic numbers. Don't waste your time. This is systems. Now, if I had 2 magic numbers and 3 constants to find, I'd probably use magic numbers because I would only need one not so magic number. But in a case where I've only got one magic number and I need to find 3 constants, yeah, I'm going to do systems. So remember, system starts with distributing, sometimes foiling. And then I want to set stuff equal to stuff. So stuff without an x equal to stuff without an x. 4 equals 4a, a equals 1. I want the x to the first stuff equal to the x to the first stuff. X equals cx. And when I divide by x, I get c equals 1. And then I want to take the x squared stuff and set it equal to 0, because I don't have any x squared stuff over there. ax squared plus bx squared. And if I divide everywhere by x squared, I get 0 equals a plus b. Conveniently, we know a. And so b equals negative 1. So my final answer will be 1 over x plus negative 1x plus 1 over x squared plus 4. All right, there you go. Well, I hope this was helpful, and I look forward to seeing you in our next video. Take care, everyone.